Hello y'all, this is Sachi. I'm making my first video in a series of 35. One video for each of the 35 multiple choice questions on a Physics C mechanics test. So I'm going to be using an example problem to explain the concept surrounding the problem and then go through step by step with solving the example problem. So hopefully at the end of this series you all have a better idea of how to solve these problems. So I'm going to jump right into it. This is my first video, question 1. So the problem we're dealing with is a plane starts at rest on a straight runway. For the first 30 seconds, the plane's acceleration A is equal to A equals bt squared, where B is a constant at 1 over 90 meters per seconds to the fourth, and T is in seconds. What is the plane's speed at T equals 30? So right off the bat, we know we're dealing with trying to figure out the velocity. And based on the information we're given with, which is essentially an equation for acceleration where it gives us b, let's just start with that. So let's plug in what we have for b into the equation for acceleration. So here's our equation for acceleration, excuse me. So let's look at what we know in the past and what concepts this deals with. So we know that there's position, we can call this x, velocity, and acceleration. Now, velocity v is the derivative of position, and acceleration is the second derivative of position, or also the derivative of velocity. So let's just write that out to make it clear. So dx is equal to v, and dv dx is equal to a. Another way to say this is the first derivative of position is velocity, and the second derivative of position is acceleration. So here we don't have to worry about position at all. The only two things we're thinking about are velocity and acceleration. But the problem with this is we're given acceleration and we're asked to go backwards to solve for velocity. So instead of taking the derivative, we're going to solve what's called the antiderivative or the integral. So to set this problem up, we're going to take the integral of this. So starting off, the 1 over 90 is a constant, so it's not going to be included in the integral. So we're going to start by writing this on this. Let's go across over here. So v is equal to 1 over 90 times the integral of t squared. Now we're going to have to define the bounds on this integral. So we know we're ending when the plane's at t equals 30 seconds. So that means this bound is going to be 30. I don't know if you can see that 30. It's a little bit hard to read. And then our starting bounds is just going to be the entire time interval that this plane is taking off. So it starts at t equals 0 seconds. So let's start to integrate this. So equals 1 over 90 times so this is just taking the interval. What this means is if we go backwards and we take the derivative of 1/3 t cubed, it's t squared. So you say 3 times 1/3 gives you 1, and then we're subtracting 1 from the exponent, so that'll give us t squared. So we're just doing the opposite of taking the derivative, which is taking the integral. So now let's start to solve this. We're gonna have So now we're gonna plug in 30 for t, and then take that and subtract when we plug in 0 for t. So the first thing is going to be 1/3 times 30 to the third power and then we're going to be subtracting 1/3 times 0 to the third power. Alright, so we know that this is 0. 0 to the third power is 0. 30 cubed is 27,000. So let's take 1/3 of this, and let's come down here. So we have 1/90 times 1/3 of 27,000, 9,000. And this is, you can pull out your calculator, you can do some mental math, but this cancels out to be 100. And then can't forget our units. We are in meters per second for velocity. So that's the answer. And on this test, that is letter C. So that wraps up video number 1. Here's the first problem from the multiple choice test and how to solve it. Thanks for watching.